Hello everyone. In our previous lecture, we had dealt with the electromagnetism. In this chapter, we are going to deal with the optics. Okay, so let's start. So the first question is, what do you mean by optics? What do you mean by optics? Basically, I hope you all must heard this name before, light. What do you mean by light? First of all, you need to understand light, then only you will understand to learn about the optics. Got it? So the first question is, what do you mean by light? If someone asks you, do you know light? Then how will you answer it? Basically, light is a electromagnetic radiation. Now the question is, what do you mean by electromagnetic radiations? Basically, there are two types of waves. First is mechanical longitudinal waves. Second are electromagnetic transverse waves. Electromagnetic transfer waves. Got it? So they are basically two types of waves. First is mechanical longitudinal and second one is electromagnetic transverse. Now the question is, what is the difference between them or what they mean by? Basically, the mechanical longitude, which I am representing by ml, is a wave required medium to propagate. Okay, wave required medium to propagate and always moves in direction of particles. So basically, you can say the mechanical longitudinal waves are the waves which require the medium to propagate and always move in the direction of particles. The particles which are carrying the wave, they always moves in the direction of the particles. And here the medium will be solid, liquid and gas or gases. Okay, so basically the mechanical longitudinal waves are these waves which can only propagate or which could only pass through the solid particle, the liquid and the gaseous medium. Okay, without these mediums it cannot go. And the example of this is the sound wave. You cannot hear the sound in the space because in space there is no medium to propagate and there is a vacuum. There is a vacuum and vacuum stands for the state when there is no medium. Okay, so that's why the one person cannot hear the sound in the space because there is no medium, and the mechanical longitudinal waves cannot move without the medium. They require medium to move, they require medium to propagate. Got it? So these are the mechanical longitudinal waves. Now let's take an example of electromagnetic transverse waves. Electromagnetic transfer waves, which I am presenting by ET in short. Waves does not require medium to propagate. Waves does not require medium to propagate and always perpendicular to particles. Got it? So basically, the electromagnetic transfer waves are the waves which does not require medium to propagate and always perpendicular to the particles, or you can say if these are the particles, okay, so the waves will always in the 90-degree angle, or you can say perpendicular. And these waves does not require any medium to propagate, so this means they can also propagate in vacuum. So basically, they can also propagate in the vacuum. Got it? And the example of these waves is the light. The light wave is an example of electromagnetic transfer waves. So let's take an example so that we could understand it more better. If this is a sun, this is a earth, okay, and both sun and earth lies in space, okay. So both sun and earth lies in space, and we all know that sun's rays reaches earth. Sun rays reaches earth, which we call sunlight. Got it? So these waves, because they are traveling in the space, and space has vacuum, or you can say no medium. So that's why the light, which is the electromagnetic transfer waves, could only propagate in this scenario. Got it? So basically, you can say the light is electromagnetic transfer waves which could propagate through the vacuum and does not require any medium. Got it? And the study of this light and various phenomena related with the light comes under the common topic known as optics. So basically, you can say optics is a branch of physics that deals with the study of light and related phenomena. Got it? So basically, optics is a branch of physics that deals with the study of light and related phenomena. Got it? So let's begin. Okay. So first is geometrical optics. Basically, we have two types of optics. The first is geometrical and the second is wave optics. We will learn about them. Okay. So first is geometrical optics. Geometrical optics is the study of light behavior using rays and simplified models, focusing on reflection, and image formation without considering the wave properties. Got it? So basically, you can say geometrical optics is a small scope of light assisted. Basically, why I am calling it small scope of light study? Because in this we only study about wave of light which generates the phenomena of reflection, refraction, and because of this the image formation. Okay, but we do not consider what are the properties of light. What are the properties of light? Basically, whether this is an electromagnetic transfer waves, whether it does not require any medium to propagate, or it can move through the vacuum. Got it? So these properties are not considered under the geometrical optics. Basically, geometrical optics deals with the light wave which generates the phenomena of reflection, refraction, and image formation without considering the wave properties. Okay, and what do you mean by the reflection and refraction? We will have an example on this in this lecture in the coming topics. Got it? So let's move forward. Here we have understood the light optics and thereafter the geometrical optics. Now come to the next point. So here is the first thing. Like you can see, have you ever looked at yourself in the mirror? Suppose if this is a mirror and this is a person standing before it, what will happen? The person will see himself in this mirror. Okay, so how does it happen? Because the light will hit this person and then it will hit this mirror, and that's how this image will be formed. So you can say if there is a person who can see himself in this mirror, because light is hitting them, getting reflected to the mirror surface and return back from the mirrors to the person. So that's how the person could see himself. Similarly, if this is a box, or you can say if this is some jug or mug in front of a person, then how he is able to see this? Because light is hitting the jug, then light is getting reflected to the person's eye, and because of this he is able to see this object. And this phenomena of hitting the light and getting back is called the reflection. It's called the reflection. Got it? And remember one thing also. And this thing is types of mirrors. Types of mirrors. Basically, we have three types of mirrors. The first type is a simple mirror, or you can say plain mirror. Second, we have convex mirror. Third, we have concave mirror. Got it? So we have three kind of mirror: simple mirror, which we also call as a plain mirror, then concave mirror, and then convex mirror. Got it? The simple mirror is used to give virtual image, original size, equidistance. Okay, so these are the properties of the simple mirror. Like simple mirror will give you a virtual image. And why we call it virtual? So let's understand. If you ever looked yourself in the mirror like this person, okay, then you will see a virtual image, because your right will be your left your left will be your right. Similarly, for this person, this is his right hand. Okay, but in this is his left hand. Got it? Similarly, his left will be his right. Got it? So this is the simple mirror first property, virtual image. Got it? Second is original size. What do you mean by original size? Because you will get image of your size or you will get image of the object size. If the object is 3 meter of height, the image will be of 3 meter of height. Okay, 3 meter of height. Got it? And thereafter the third point was equidistance. Equidistance means if the person is standing 3 meter away from the mirror, then the image will be formed 3 meter beyond the mirror. Got it? If the person is standing 3 meter away from the mirror, the image will be formed 3 meter beyond from the mirror. Got it? So that's why it is the equidistance. Got it? Now the second ones are the convex and the concave. Convex and the concave mirror. Basically, the convex mirror is also known as diverging mirror. The concave mirror is also known as converging mirror. Got it? Convex mirror is basically known as a diverging mirror because whenever the light hits the convex face, it always gets deflected away. Got it? So that's why it is called the diverging mirror. Whereas whenever lights hit the concave surface, it always gets converged. So that's why it is called converging mirror. Okay, we will have a discussion over the image formation by these two, convex and the concave mirrors, in our upcoming lectures. Okay, till then just remember the point: convex is a diverging mirror and concave is a converging mirror. Okay, now let's forward. Now there are the lenses. So basically lenses are the magical glasses that can help us to see things clearly. Okay, so you have basically use lenses to see clear image or to see magnifying image, right? So basically lenses are used for these two works: first to clear the image and second for the magnifying image. Okay, to clear the image is basically used for the people having eye problem. For the people having eye problem, it is used to clear the image, and for minute objects, it is used to magnify the image. Got it? So they are basically two roles for the lenses. Got it? And lenses are also of two types: convex lens and the concave lens. Got it? So remember, in case of mirrors, the convex mirrors were the diverging, but in case of lens, they are the converging ones. Okay. Similarly, the convex mirrors were the converging, but in case of lenses, they were the diverging ones. Got it? So also the image formation of lenses will be included in our upcoming lectures. Till then, just remember the facts which I have told you. Got it? Like here is written down. You might have seen people wearing the glasses to help them see better. Got it? Because the lenses are basically used to organize the light in a way so that we could see the objects clearly. Got it? If we having some eyes problem, and if our eyes are not so good to see the distance object or to see the close object, basically we will have a discussion over it in our upcoming lectures. Till then, just remember these points. And the second is, if you are required to see some minute things, and because if this is a minute thing, because the amount of light reflected by these minute items is not sufficient for our eyes to catch. So that's why we are not able to see this minute thing. But if this is a minute thing and we put lens and then we are seeing the thing, this is our eye. Okay. And when we are seeing the things, then the lens will magnify the amount of light getting reflected, and that's how we would be able to see the object clearly. Got it? Now come to the next point. It is the wave optics. Okay. So remember, I had told you there is a two parts of the optics. First is geometric and second is wave optics. Basically, the wave optics is the bigger scope. Basically, the wave optics is of the bigger scope. Reason? Because it's just not only consider the wave of light, but also consider the properties of light. So you can say the wave optics just not covering the wave of light, but also consider the properties of light. Got it? So it is a bigger scope branch of the optics. Got it? And this comprises various phenomena like interference, polarization, refraction, reflection, and refraction. Got it? So let's understand them one by one. First is, there are some points which you need to discuss. The first is, have you ever seen a rainbow in the sky after it rains? Rainbows like a magic light show in the sky. It happens when light from the sun splits into beautiful color as it passes through raindrops in the air. This is called the dispersion, and it is a part of wave optics. As I have told you, wave optics is a bigger branch. So let's understand. Like after rain, there is some water droplets in the sky, and these water droplets act as a small mirrors or lenses, you can say. Okay, or basically most probably, and the most clearly word is reflecting surfaces. Okay, so whenever the rains happen and when the rain disappear, okay, there are some water droplets still existed in the sky, and when the sun rays passing through them, then they got divided into 7 colors, which form the rainbow. Okay, and this entire phenomena comes under the common term of dispersion. Got it? Now let's move forward. So first is the interference. Okay, the interference is the phenomena occurs when two or more waves interact, leading to an reinforcement, constructive interference, or cancellation, destructive interference. Got it? So let's suppose this is a wave originating from A and this is a wave originating from B. Okay, so if these waves get collided, then this will be destructive interference. Got it? But in another case, if the wave is originated from A and the wave is originated from B, and these waves get in converging zone, then it will be converging. Okay, intensity during destructive is low, whereas intensity during constructive is high. Okay, so basically interference is the phenomena when the light waves either get collided or either get merged. Okay, so when they collided, called the destructive interference, and the intensity of the light is getting low. But when they when they merge together, the intensity gets high and it is a constructive interference. Got it? Example: when you see a pattern of colored lights on soap bubbles or oil spills, like a magic dance of light waves, this dance is called interference. It happens when different light waves meet and create colorful patterns. Because if this is the water droplet, or you can say this is the soap bubbles. So in this soap bubbles, light is getting entered from various sources and getting interference. Because of this, you can see various colors visible inside the soap bubbles and the oil spills. Got it? Now come to the polarization. Okay. So basically, polarization is a filtration of light. Okay, so basically the light which you are seeing around yourself, or you can say the white light is comprised of various lights, or you can say the 7 colors: violet, indigo, blue, green, yellow, orange, and red. Okay, so these 7 colors are comprised into the white light. Okay, so basically during polarization, the light waves strike a plane and only the few light would be able to get through it. Okay, or you can say the filtration process. Like in this diagram, you can see there are 2 light waves. First is orange, second one is blue, and this is the plane where they hit. So after hitting the plane, only blue light is able to get through it. So this is the process of polarization. Okay, like examples, if you ever have been wear sunglasses, then you must know, then sunglasses, your eyes will get will get dim light because the sunglasses act as a filter, and when the light strikes the glasses surface, then only a few light would be able to cross it. That's why your eyes will get a dim light and your eyes will get a pacify approach. Got it? Now the reflection. Basically, I have told you, whenever the light hits an object, it gets reflected back, and this phenomenon is called as reflection. Remember, if the person seeing himself in the mirror, because light hits him, then hits the mirror, then reflected back to him, and because of this reflection he could see the image in the mirror. And always remember, the angle of reflection presented by R will be equal to angle of incident, or you can say basically the angle of incident will be equal to angle of R. The angle of incident will be the angle of the hitting ray, the ray which hit the surface. Got it? Like the example which I have told you, if you have a shiny mirror in front of you, when you look at the mirror, you see your own face looking back at you, because the light from your face bounces off the mirror and comes back to your eyes. This bouncing back of light is called reflection. Okay, so light, here you are standing, then light hits your face, then hits the mirror surface, and then reflected back to your eyes, and that's how you are able to see yourself in the mirror. Got it? Now you can also see the reflections in the still water like a pond or a calm lake, because these are also the reflective surface. Got it? Like if the water surface is calm, then the light will be reflected easily. But if the water surface in the motion, then the light will be reflected here and there. Okay, so that's why you are not able to see yourself in the disturbed water, but you can see yourself in the calm water. Okay, now the refraction. Remember, whenever the light passing through one medium to another medium, so it get deflected. Okay, and this deflection is known as refraction. Like in this scenario, the light is coming from the gaseous medium hitting the solid medium, then light should pass from this, but light is passing from this because it get deviated. Okay, let me build it here. The light is coming from this side, then it was supposed to cross this side. Okay, but light is crossing from this because it get deviated in the middle. And this is called the refraction. Similarly, the angle of I means the angle of incident will be equal to angle of refraction. Got it? So in this chapter we have finished the optics phenomena. In our next lecture we will start with the fluid mechanism. Till then, thank you.